Hi and welcome to this SOLIDWORKS tutorial. In this tutorial I'm going to assemble a wooden toy coffee donut shop I designed within SOLIDWORKS. I started my design as a multi-body part, as I often find this the best way to hash out an idea into 3D quickly and play around with it before moving into an assembly. Once I'm happy with my design, I export the solid bodies out to create an assembly. Within the assembly, I could then add any mates to the toy which would imitate play, such as moving the coffee filter, opening the drawer, turning knobs, or turning the shop sign from open to closed. In the assembly, I used Hole Wizard to be able to add fastenings to construct the toy. Opening the feature, you can see I had to ensure the feature would apply to the toy at part level, so Propagate Feature to Parts is checked. You can see the highlighted blue parts that the Hole Wizard applies to. If you'd like to play around with this design, it is available to download from the SOLIDWORKS blog. All part files, including the accessories I created for the toy, are in the download. You may notice as I bring in some of the parts, they already have dowels inserted into them. This is just to speed up the assembly of the toy for the tutorial. To begin, I'm starting with a new assembly. And I'm opening the base, left, middle and right panels. I'm going to assemble in stages. Drop the base in using Enter. This will snap center to the assembly. Then just drop in the other parts like I do, near where they are going to be placed. I'm mating by selecting the two faces I want to mate holding control, and SOLIDWORKS will give me a range of mates I can choose from by my selections. The three main panels will be placed using 3 coincident mates. The outer panels need to mate to the side face of the base panel and be flush to the base from the bottom to the front faces. The middle panel needs to slot into this hole, so the inner faces of the slot are used to line this up. Once those 3 main panels are mated, I can use Insert Components to bring in the main shelves and front panel. Again, I'm just dropping these near where they will be positioned. I created slots for the coffee capsule shelf and coffee machine base to minimise screws. They will be held in place by the slotted grooves and the screws from the outer panels when tightened, which would secure the parts. So I'm starting with the coffee shelf here, mating the sides to the middle panel using a coincident mate. Then I'm lining it up within the slot using the inner slot face of the mid panel and the front face here. Then finally level it off to the bottom of the slotted groove here from its bottom face like this to fully define. I'm repeating the same process for the coffee machine base here, ensuring that it is fully defined within the slot. Then for the front donut shop panel, I'm mating the back face of the panel to the back face of the shelf. Next, the side of the panel should be mated onto the inner right side of this panel. And finally, make the bottom edge onto the top of the base panel to fully define it. Now we can bring in some more parts into the assembly. Selecting the donuts display, front counter and back counter parts, the coffee machine front and cup holder. Drop all the parts into the assembly like this. You can see some of these parts have dowels in place already to help with the toy construction. These add more structure to the toy once all the screws are in place. The first panel I'm mating is the front counter panel. This panel fits against the left side panel, onto the base panel, and then flush to the front of the base panel like this. Moving on to the donut display, this also has some grooves to slot into within the middle and left side panel, so I'll be using this feature to mate the part into. The back counter panel is mated in the same way as the front panel. Again, I'm using 3 coincident mates to fully define the panel, including front, side and bottom. I think of it as defining a part across its X, Y and Z axis. The cup holder panel should be mated onto the left side panel and then mated into the small slot here within the middle panel. Finally, I have the coffee machine panel. The bottom of the panel should be coincident to the bottom face of the coffee shelf here. This needs to be mated onto the front of the coffee shelf and sit against the right panel to fully define it. Bringing in the next lot of parts, select the coffee machine, donut shop sign, plastic counter, the knob and the drawer, and open them. Drop in one of each part until you get to the knob. Before you drop this in, select the little pin icon here to drop in 2 of them. Then drop in one of the plastic counterparts and close insert components. Now most of these components will have some sort of freedom in movement using mates, but first I need to make the plastic counterpart into place, as this will be fixed. You will see there are some grooves already applied to the left panel to mate the part into. The bottom of the parts need to mate inside of the slot of the front counter panel here. And finally, use this flat face of the front of the part to mate it coincident to the inner face of the slot here. Now I can move on to some less static mates, which add some playability to the model. Starting with the coffee machine filter here, I need to mate it onto the coffee machine first, using a coincident mate between these 2 faces, and adding a concentric mate between these 2 edges to center the filter into the machine. Ensure lock rotation is unticked, as rotation needs to be free here. We'll come back to this part in a moment. I'm just going to make the sign to get it out of the way. To do this, I'm making its inner cylindrical face concentric to the pole of the front shop panel here, again with free rotation. To center the sign, I am using a point sketch I created in the center of the donut sign panel, and one in the center of the front shop panel. You will need to drop down the part features and make the sketches visible first to use them. Once they're both selected, I can apply a coincident mate. This allows me to spin the sign from open to closed. I like to re-hide the sketches once used, just to keep my model tidy. Going back to the coffee machine filter, I want to restrict the rotation of the handle so that it can't hit the panel sides. For this, I'm using planes. Within the part file, I added a plane through the center of the handle like this, and a plane center to the coffee machine. I'm making them visible for the mate. Opening the mates icon, select Advanced Mates and select both planes for the mate selection. Check the limit angle icon here and input 133 degrees for the maximum position and 47 degrees for the minimum. Uncheck flip dimension and check this mate alignment here. Within this box, you can test out current positions to view your part at different angles between your minimum and your maximum values. Adding the mate, I can test it out. Limit mates like this can simulate play of the toy, which can be fun to do, but it also serves a purpose. I can test out how the toy works, or be used to create animations for potential toy buyers to bring it to life. Before we move on, just re-hide the visible planes. For the drawer, I need to make the bottom face here onto this face of the base panel and make coincident. The side of the drawer needs to be mated to the right panel here, but it needs a distance of 1mm. Finally, I'm going to add another advanced mate type. In this case, it's a limit distance mate between this face and this face of the front panel here. My maximum for this would be 118mm. You can see the stopper of the drawer hits the inner groove to the maximum it can go to. This ensures that the drawer can't fall out during play. The minimum value needs to be 0mm, allowing the drawer to fully close. Ensure all your settings and mate alignments match mine before applying. Now I can drag the drawer in and out until it stops. My last moving component is the coffee machine knobs. These are done in the same way as the coffee machine filter, using planes and angle limits. First, I need to mate them into the coffee machine panel using a coincident mate and a concentric mate to allow them to rotate within the hole. Then I need to make plane 1 visible under the knob part. And the coffee machine panel also has a plane to make visible here. Selecting the mate icon and advanced mates, select this plane and one from the first knob here. Using limit angle, import 270 degrees for the maximum angle and keep 90 degrees for the minimum. You will need to flip the dimension here. Once applied, you can test it out. Repeat this for the second knob and then apply it. The part should only turn to point the coffee settings, only moving 180 degrees from one side to the other. With the part assembled, I am throwing in and placing all my accessories. If you want to, you can just skip this next step. This is just an aesthetics part that I usually need to add to show buyers the fully assembled toy and how everything fits. If you do want to add them, they are all mated quite simply. A coffee pod is mated bottom face up within the cup, as they have a coffee design decal applied to each. The coffee cup is mated into the hole using the face of the cup and the top edge of the hole, like this. The remaining pods are in the coffee shelf, all mated concentric to the slot and spaced apart with a distance of 1 mm. The ring donuts are mated using 2 tangent mates from the front and back of the base of the donuts onto the donut display here. The caramel donuts have a flat face, so they're easier to mate into place. The accessories aren't fully defined, they are quite free on their placement, so you can move them around. Finally, I applied my smart fastenings to fully assemble the toy. I apply them panel by panel. Selecting smart fasteners and the hole here, check add. Pan crosshead screws will add into each hole like this. Again, as I mentioned earlier, all of this work is done ahead of the assembly, and the hole wizard tool was used and applied to all parts. Next is the middle panel. You can use populate all, but I have dowel holes within the model and I don't want it to add to those too. Also, if you want to avoid any issues with the design, sometimes I find it best to add fasteners in small groups. Finally, apply smart fasteners to the last panel here. And there we have the fully final assembled toy. From here you can create drawings, bill of materials, or render your design in SOLIDWORKS Visualize. Here is a mini animation of my design that I created in Visualize. I hope you enjoyed this tutorial. Thanks for watching.